Alright, another episode of Forge Diaries. I just want to show these tools that I've made and talk about them, and I actually have video of how I've made them, so that'll be interesting to watch. Here's what these tools are. I've made in previous episodes of Forge Diaries, you've seen how I've made these spring tools that have the correct bevel or angulation built into them so that they'll lay the correct bevel for the cutting edge and the spine edge of a Shinogi-Zakuri katana, and I've shown a practice piece that I've run through here and how really amazingly symmetrical those turned out. But they still require some truing up. As you run a piece of metal, let's grab a scrap piece of metal. As you run a piece of metal through these, if you don't, let's say that if I have them perfectly horizontal, then it leaves the metal pretty straight. But if there's even a slight downward angle on it, then it puts a U-shaped bend into the metal, and that requires straightening. And this is just expected. There's nothing unusual about that. You have to take that over to the anvil and true it up and straighten it out. What can be worse is if you have a little bit of a U-shaped bend in the blade bevel, you take this instrument off, put the other one on, turn it over and go into the spine. If you made the same angulation error with the spine as you did with the blade, you get a corkscrew in your blade. It literally corkscrews like this, and getting that out can be, it's not the end of the world. You heat it up and flatten it out, but it requires extra time. So I've made a tool to make truing up the blade, making it perfectly straight. So after having used these, then I'll be able to use these to make the blade perfectly straight. So what I've done is I've made these pieces of metal with the same angulation. Now I've crowned the edges. You can see how they get wider here and here. That's just so that the edges of the tool won't leave marks in the edges of my work. But the central channel here is quite uniform and quite straight. And what I've done is I've built into these two instruments the correct angles. This is the correct angle for the blade, and it ends in just a little bit more than a 1/16 of an inch, which is where the piece should be before you heat treat it. And this one is shaped for the spine edge. So this is the blade edge and this is the spine edge, and this one's quite a bit wider at the base. And I would not actually sink, well, I would sink the blade all the way to the base of this one. The spine would only go part way down into this one. You don't want your spine edge to be anywhere near that thin. But, so I've got these two instruments. I still am going to weld a piece of square pipe onto the bottom of them so that I can insert them into the hole on my anvil. And then I'll be able to run the blade through this to put the bevel on, then turn it and run it through these to true it all up, straighten everything out perfectly. This is going to make straightening my blades a lot easier as I forge them. Like, this is going to take, between these two tools, I'm going to take hours and hours and hours and hours off the work because I'm not doing it totally by hand. The way I made this one was I made this piece of metal that has the shape, that has the correct angulation for the blade, which is a 15-degree angle. I marked into the top of this and the bottom matching and drew all the lines so that all I would have to do is cut a slice out. And that's what I did. I took my angle grinder, I put a cutoff wheel on it, and I cut that piece out, and I have video footage of me doing the cutting. With this one, I cut a line through it just like this, but I did a lot more work. This one is tooled. I used power tools to do this one, and it only took me about 40 minutes to make. This one I decided to forge just for the fun of it, and this one literally took me all day. This one yesterday. This took most of my waking hours to make this one, and I have video footage of me forging this one. But what I did was I cut a single groove through it using the angle grinder, and I show that in the video. Then I took a piece of metal and I laboriously ground into the surface of the metal the exact angulation and shape that I wanted. Then I heated this up in the forge and I pounded the metal into that so that it would leave the correct shape. It's perfect. I love it. I made the mistake of hardening the piece of metal and I didn't harden it completely. I only heated it up to cherry red before I hardened it. I didn't want it to just deform as I pounded it through the hot metal, so I heated it up to cherry red. This is high carbon steel, and toward the end of the procedure, as I was pounding on it, it broke in this location. And I'm sure that's because the hot metal, obviously I lost the heat treatment here, so I had hardened steel here and softening steel here, and then I set this down here and it cooled, or actually I think what I did was I think I quenched it in the bucket, and that caused it to develop cracks, and at some point before the end of the procedure it broke. It chipped. So this is just a piece of junk steel now. But fortunately I was nearly done with the process and I got the tool finished anyway. So I've got video of me doing this process, and I'll show that in a minute. So I just wanted to show some new tongs that I bought. These are my previous tongs that I had, and they're just a generic tong. They don't have any kind of a grip or anything on them. So when you hold a piece of metal like this, well, it holds them tight enough, I guess. If you try to do anything with the metal, especially lateral movement, it just slips and slides, moves around. So supposing, for example, I wanted to take this and lay it against the anvil at an angle up like this, and then pound on it, it would move all over the place. So I ordered two different kinds of tongs. These are called box jaw tongs, and you can see that the tip of them has this box, and the box is set to the size of stock that I use most commonly, which is 3/8 of an inch by 1 inch. That's the starting point for making the blades that I make. You can see how it grips this metal here, which actually this bar is 1.5 inches, but I've cut a 1 inch tab in it so that I can hold it with these box jaw tongs. And because of the way it grips them, the metal can only move just a little bit. So it'd be great for holding. If I could hold it like this, and it would in fact stay at this angle, and I could pound on the tip of that or pound on it in any way I wanted, and it wouldn't move. It doesn't move around. Okay, so this is a really useful type of tong. It's called box jaw tongs. And then I got a separate kind of tong, and it's similar to the box jaw tongs. It has grippers like this. And it is also set to hold 1 inch by 3/8 inch. The difference with these tongs is that it orients the metal differently. When my hand is oriented this way, the metal is vertical. Whereas with the box jaw tongs, these ones here, when the metal when the handle is oriented vertically, the metal's turned this way. So one thing that these tongs are particularly good for is quenching swords. When the sword is hot enough that it's ready to quench, if you're holding it sideways like this, so that the blade's horizontal, it can actually bend and sag because it's so long and heavy. When it gets that hot, it'll actually sag and curve on you, which is not good. And with these tongs, I can grip the sword like this and comfortably hold it this way. And I would hold it with the spine down. So if there's any kind of sag, there probably won't be any sag this way. There might be this way, but there probably wouldn't be this way. But if there is any little bit of sag, it would be in the same line as the curvature that I anticipate the sword having anyway. So anyway, these two tongs I got for holding the metal, and they do a much, much better job. They're particularly good for things like this. This is a practice piece I did, and it has a ridge. The handles all have this ridge in them. The shinogi line continues out into the handle as well. And when you grab that with these tongs, because it's a high point, there's no grip at all. It just fulcrums off that high point, and they move around like crazy. Whereas both the box jaw tongs, and I don't remember what those other ones are called, but both of these gripper tongs, hang on a second, do a great job holding this. And while it's capable of moving just a little bit, it really is just a little. The box holds that handle tightly, grips it from above and below. And so, anyway, much better tongs.